Hi everyone, this is Jeff Wallace and showing off Project 10. It's my quadcopter. It's still not back in the air, so I just have everything on a tabletop for now. I'll walk through the hardware in a minute, but for now, just to show the demo. So here is the IMU data. This terminal is my host computer, and just to show if I move it around, data is live. It changes. I'm not having it sample all that frequently, but it's okay for the sake of this project. There's another terminal um, getting the GPS data from the Raspberry Pi, and this is also a host terminal. And last but not least, the webcam. So let me move this around. You can see this is live too. My lovely messy table. Put that back down. So that's the demo, and I'll take you through quickly the hardware and the software. So hardware, we'll start with the IMU path. That's pretty straightforward, but the most convoluted of any of these tasks. So I have a little Arduino Uno with the breadboard. Here's the IMU, and here's my Raspberry Pi. So you see here these two lines of the SDA and SCL of I2C. So the way the data is flowing is the IMU is a I2C slave to the Arduino, and the Arduino is a slave to the Raspberry Pi. The Arduino is being powered over USB from the Raspberry Pi. The IMU is receiving power from the Arduino. So you see we have, this is the ground, and we have a 5-volt power going, that yellow wire there. That's powering the IMU. Then we just have a little debug LED for just to have it flash every time it's writing a message, or rather reading a value from the IMU. Just did that with debug. I was having some problems having serial work at the same time as I2C, and I wasn't able to figure that one out. So just using an LED to show me that something's going on. So that's it for the IMU. Webcam, very simple, and the GPS puck. They're both just plugged straight into USB, so that's all there is for the hardware. Onto the software. GPS is the same as I had done in, I guess that was Project 6. So I just have configured the GPS daemon running on the Raspberry Pi to accept connections from any address, and I'm just I can even just kill this and show the command I ran. So let's see, there we go. So I'm just running cGPS here and passing in that IP address of my Raspberry Pi, and run that, and there you go. That's easy enough. The video is just using the motion package, which if you go back and look at the address bar, see if I can focus this. There you go. Yeah, we're just connected. Same IP address, 8081, so just different port as the video. And then last but not least, the IMU, which is probably the most convoluted. Let me stop this, and I can show how it works. So I have two pieces of software running on the Raspberry Pi. So I have this IMU interface. That's a C script, or a C, I guess it's C++ actually. C and C++ that is reading the IMU data over I2C, and it just writes the values it receives to standard out. And then, because it's much easier to do networking, in my opinion, in Python, I just have a simple UDP forward script which reads from standard in and just writes those values, sends it over UDP, which then I have another script on my host computer, another Python script, which is just connecting to that port and reading those values and displaying them. So that's how that works, and we'll actually I can go through each piece of software. So first open up the C and C++. So I'm doing this directly on the Raspberry Pi, so there's no syntax highlighting, so I apologize about that, but a little bit easier to iterate. So I have our imports up here, a little structure that represents the data that's coming over the I2C, so XYZ, roll, pitch, yaw. We can ignore the swap function. I was using that to debug when I wasn't sure if I needed to byte swap or not. Some constants, a signal handler to close gracefully. So we just parse some arguments in the main function, taking the device name, the target address. So that's the address that we want to talk to the slave I2C device. So in this case, that would be the Arduino. And a read period, which is how frequently we want to request data from the I2C slave. Initialize the signal handler again. Then we just do some checking to make sure that we're targeting a valid address. Then we open up that device, that I2C device. We just give it a little bit of time to initialize. Definitely not necessary, but just for debugging purposes, I put that in to see if I was running into some strange condition. Then we set up the I/O for the I2C device to say that we want to talk to the slave at a given address. And then we have a little loop down here, which is our main loop, so we're checking, see while we're not shut down, and the shutdown flag is set by the signal handler. So this will turn true, this will turn true when we hit Control C. We write to the address we want to read from, which is always 0, and then we read the IMU data. So we loop over until we get the right number of bytes, which is the size of this vec3 structure. Because we're reading directly in to a vec3, so we have this vec3 data here, and we're just reading directly into that buffer. And when we do that, we just print directly as standard out. That's the only thing going as standard out. Everything else in here, you notice up top, some of the debug prints are all going to C error. So we only write to C out the data that we're interested in, which is the roll, pitch, yaw values. And then we wait until the next sleep duration. And if we close gracefully, we exit with success. So that's it for that piece. Let me close that out. And now we'll look at the next script, which is this UDP forward script. So this is going to read from standard in and send the data that was received by that other script to the host machine. So this is very simple, just parsing with some arguments. Well, we're not interrupted, so we don't have a Control C. We accept a connection on a socket. We read a line from standard in. We split it by spaces. We convert the values to floats, and we print it out and send it over the socket. So very simple. And equally simple. Let me open this up. Is the script running on the host, and yeah, we have syntax highlighting here, thankfully. So very similar and very, very simple. All we're doing is taking the host import, creating a socket, connecting to it, and just dumping out any data we received to echoing it to a local terminal. So that's it, and that's all of the software. And now we've gone through everything, so that's it. Thanks.